Welcome to our third webinar on high-precision bearings. Today we will be looking at a particularly practical topic, the correct arrangement of high-precision angular contact ball bearings, also known as spindle bearings. In this webinar, we'll explore why certain angular contact bearings are always installed in pairs. We'll take a closer look at the common arrangements, O, X, and tandem, and explain which arrangement is best suited for which application. You'll also learn the benefits of pre-matched bearing sets and what is meant by a universal design. Finally, we'll discuss the effects of temperature changes on bearing performance. And as always, we'll wrap up with a quick preview of the topic for our next webinar. When multiple bearings are deliberately installed together in a defined arrangement, this is called a bearing pair. Usually these pairs consist of two bearings, but for more demanding applications, three or more can be combined. Then we call it a bearing set. The reason for pairing bearings is straightforward. In many precision applications, a single bearing simply cannot provide the required stiffness and load distribution. This is essential when higher rigidity, defined preload, or axial load support in both directions is needed. Pairing the bearings allows forces to be distributed precisely and the bearing arrangement to be optimized for the application. The key requirement for effective pairing is that all bearings in the set have exactly the same preload. The system only works when the bearings share the load evenly and act together. When two or more bearings are mounted next to each other, they can be arranged in different configurations, each offering specific advantages. Let's start with the O arrangement, also called the DB arrangement, which stands for double back. In this configuration, the contact lines of the two bearings point outward, forming an O shape. This arrangement provides excellent resistance to tilting moments and allows axial loads to be supported in both directions, making it ideal for spindles or rotating systems with changing loads. The X arrangement, also called DF for double face, forms an X shape as the contact lines of the bearings cross. Compared to the O arrangement, the X arrangement is slightly less rigid against tilting moments, but it compensates better for shaft misalignment. Axial loads can still be supported in both directions. This arrangement is often used when shaft deflection or minor alignment errors are expected. In a tandem arrangement, abbreviated DT for double tandem, two or more bearings are positioned so that their contact lines run parallel. This means both bearings support loads in the same direction, effectively doubling axial load capacity compared to a single bearing. Tandem arrangements are used when very high axial loads need to be supported in only one direction, such as in heavily loaded tool spindles. Since they cannot take axial loads in the opposite direction, they are almost always paired with an O or X arrangement on the opposite side of the shaft to safely support counterforces and radial loads. In many applications, not only is it important to pair bearings, but also how it's done. Pairing bearings individually is possible, but it requires deep knowledge and experience. That's why many manufacturers offer pre-matched bearing sets, two or more bearings that are already matched at the factory. These sets are designed for O, X, or tandem arrangements and can be installed directly without additional adjustment. Factory-matched sets are clearly labeled with the manufacturer's codes, like DB, DF, or DT, and often include arrows on the outer ring to simplify installation. The main advantage is obvious. Factory matching reduces assembly time and minimizes the risk of incorrect pairing. However, pre-matched sets are usually more expensive and not always available in every variant on short notice. In addition to fixed, pre-configured bearing sets, there are also so-called universal designs. These bearings are manufactured at the factory so they can be flexibly combined with identical bearings in O, X, or tandem arrangements. When installed correctly, they automatically achieve the intended preload without the need for spacer shims. To ensure this interchangeability, universal bearings such as SU, single universal, DU, double universal, and QU, quad universal, are carefully inspected during production, for example, to confirm identical face geometry on both sides of the bearing. For multi-row variants such as DU and QU, there is also an additional check of bore and outside diameter tolerances for each set. Whether a bearing is suitable for universal combination can usually be determined by a marking on the outer ring or packaging. For example, UO, UX, or simply U. Exact details can also be found in the manufacturer's technical documentation. Universal designs are particularly suitable for standard applications, where high flexibility and simplified bearing inventory management are important. They help streamline logistics, reduce design planning time, and enable quick servicing in the event of a failure. However, it's worth noting that in specialized applications, such as very high speeds or extremely tight manufacturing tolerances, purpose-matched sets are often the better choice. A frequently underestimated factor in selecting and designing bearing arrangements is the influence of thermal effects, not from the ambient temperature, but from the heat generated within the bearing itself. This heat is typically caused by friction at high speeds and has a direct impact on bearing performance. In O arrangements, where bearings are axially preloaded against each other, different thermal expansion rates between the shaft and housing can lead to an unintended increase in preload. The cause is a temperature difference between the inner and outer rings, which shifts the axial position. This can result in higher friction, further heat buildup, and, in the worst case, premature bearing failure. X arrangements are somewhat less sensitive in this regard, as their geometry can better accommodate misalignments in differential expansion, though the issue still fundamentally exists. Tandem arrangements are also affected by such temperature differences, especially when multiple high preload bearings are mounted in series. Without proper counter support or relief, the forces generated can accumulate and amplify one another. Most high-precision bearings are designed for operation between -30 degrees Celsius and +100 degrees Celsius. However, the actual performance limit depends heavily on the lubricant, cage material, and exact installation conditions, as well as the specific type of loading during operation. Particularly with short bearing spans, high speeds, and rigid preload, precise thermal design is critical. In such cases, it's advisable to evaluate the application together with the manufacturer, especially if ceramic rolling elements, special preload levels, or extreme speed requirements are involved. That brings us to the end of this webinar. You now know why and how high-precision bearings are paired, the different arrangement types available, and the key points to consider when selecting and installing them. In our next webinar, we'll be talking about high-precision cylindrical roller bearings, their characteristics, special features, and possible applications. We look forward to having you join us again. Thank you for your attention.